We are going to discuss some more problem in the miscellaneous exercise of integration, of which the first one is an indefinite question, integral root of tan x plus root of cot x dx. This question is a very important question and also it is a previous year board exam question. Now here this expression contains two radical symbols. So better substitution for this one. I think this one we hadn't discussed. Now, to integrate an expression which involves radical symbols, sometimes we can use the substitution, the function inside the bracket, function inside the square root as t square. That is, here assume tan x is equal to t square or cot x is equal to t square. Better you take tan x is equal to t square. And differentiating 6 square x dx is equal to 2t dt. And dx is equal to 2t dt divided by 6 square x, and for that 6 square x you can write it as 1 plus tan square x. Here tan x is equal to t square, so 1 plus tan square x can be written as 2t dt divided by 1 plus t raised to 4. Now replace the function root of t square plus 1 by root of t square, root of 1 by t square into dx. For that dx it is 2t dt divided by 1 plus t square. Simplifying this one, t plus 1 by t plus 2t dt divided by 1 plus t raised to 4. Now by taking this LCM, t square plus 1 divided by t, and this t will be cancelled, divided by 1 plus t raised to 4, and 2 into t square plus 1 dt divided by 1 plus t raised to 4. This is another important structure. The numerator is t square plus 1 and the denominator is t raised to 4 plus 1. This one belongs to a problem like this: integral x square plus 1 divided by x raised to 4 plus x square plus 1. That minus plus numerator and denominator. Okay. And for solving this type of question, and it is a special question given in the NCERT exercise, and we must study this integration process also. To integrate this one, you divide numerator and denominator by t square. This is the strategy for integrating this one, dividing numerator and denominator by t square. So the first expression becomes, this is 1 plus 1 by t square dt divided by t square plus 1, t square plus 1 by t square. See the denominator of this one, t square plus 1 by t square, that is of the form a square plus b square. We can write it as a minus b the whole square plus 2ab. A minus b the whole square plus 2ab. ab means t into 1 by t, that 1 and that is 2 into 1. Why did we change the denominator like this? And the method for changing the denominator as a square plus b square as a minus b the whole square plus 2ab, that leads to the numerator becomes the derivative of the denominator. Why? Because t minus 1 by t. What is the derivative of this one? T. Derivative is 1. What is the derivative of minus 1 by t? That is plus 1 by t square. So if the numerator is t1 plus 1 by t square, write the denominator as t minus 1 by t the whole square plus 2. If the numerator is 1 minus 1 by t square, you can write this one as t plus 1 by t the whole square minus 2ab, minus 2. So these are two methods involving in the expression which involves x square plus 1 divided by x raised to 4 plus x square plus 1. Note it. Now the remaining portion is easy because you assume this t minus 1 by t as u, and its derivative du is 1 plus 1 by t square dt, and the problem becomes integral 2 into integral du divided by u square plus 2, and that can be written as 2 into integral du by u square plus root 2 the whole square. This is of the form x square plus a square. X square plus a square. What is the formula for x square plus a square? We know the standard integral for x square plus a square, that is 1 by a, 1 by root 2, 1 by a tan inverse u by root 2. Now simplifying, that is root 2 into tan inverse t minus 1 by t by root 2 plus c, and change t as u as t minus 1 by t and t as what? T square is equal to tan x. So what is the value of t? T is equal to root tan x, and after taking LCM you will get the answer of that one as tan inverse root 2 into tan inverse tan x minus 1 divided by root 2 tan x. Question number 2. Integral 0 to pi x dx by a square cos square x plus b square sin square x. This is another special type of integral question. The denominator involves cos square and sin square. A square cos square x plus b square sin square x. The method for integrating this one is either you divide the numerator and denominator by cos square x or sin square x. Before that, by the property of integrals, I told you if the numerator is an algebraic function x, to avoid that x, you apply the properties of integrals. That is, I is equal to integral 0 to pi minus x, for this x you can write it as pi minus x dx by a square cos square pi minus x plus b square sin square pi minus x. And numerator is pi minus x itself, and cos square pi minus x cos square x തന്നെയാണ്. cos pi minus x minus cos x ആണ്, പക്ഷേ സ്ക്വയർ ഉള്ളതുകൊണ്ട് a square cos square x plus b square sin square x. Now adding these two integrals, we will get 2i is equal to 1x will be cancelled from numerator, and the expression becomes pi dx by a square cos square x plus b square sin square x. നമുക്ക് pi outside എടുക്കുകയും ചെയ്യാം, and the method for integrating this one is dividing by cos square x. So you divide this expression by cos square x, and 2i is equal to pi into integral 0 to pi. Numerator cos square x കൊണ്ട് divide ചെയ്താൽ 1 by cos square x, that will be c square x, and the first term in denominator is a square plus b square tan square x. Now the integration step is very easy because you can see the numerator c square x as the derivative of tan. So better you assume u equal to tan x and d equal to 6 square x dx, and change the limit also. When x is equal to 0, u equal to 0, and when x is equal to pi by 2, u is equal to infinity. Now the problem becomes pi into integral 0 to infinity du divided by a square plus bu the whole square, that is pi into 1 by a, the integral of this one, 1 by a tan inverse x by a bu by a whole divided by b, where b is the coefficient of u. Now put the limits, that is pi by ab into tan inverse bu by a within the limit 0 to infinity. Put infinity first, tan inverse infinity in the limit you can take it as pi by 2, otherwise it is not defined. So pi by ab into pi by 2 minus 0. So the final answer of this one is pi square divided by 2ab. Next question is also from miscellaneous exercise question number 19. That is sin inverse root x minus cos inverse root x divided by sin inverse root x plus cos inverse root x dx. It is also an indefinite question, not a definite one, and it is little important also. And everybody knows the denominator sin inverse root x plus cos inverse root x. What is that? And this is from our inverse trigonometric function. The answer of this one is pi by 2. You substitute pi by 2 for that. And this is a formula. Sin inverse root x plus cos inverse root x is equal to pi by 2. Again, we can write the numerator using the same formula. You write it as 2 by pi sin inverse root x minus pi by 2 minus sin inverse root x. So the first expression becomes 2 sin inverse root x minus pi by 2 along with 2 by pi. Now take that you multiply that 2 by pi 2 inside the bracket, you will get 4 by pi sin inverse root x, and this pi and 2 will be cancelled, so it is minus 1 dx. The second part integral is very simple, because this integral of 1 is x, and I told you an expression contains some radical symbol. We assume the substitution for that one to evaporate the radical symbol in this one. Radical symbol പോകത്തക്ക രീതി വേണം നമുക്ക് സബ്സ്റ്റിറ്റ്യൂഷൻ കൊടുക്കാൻ. സോ ഐ തിങ്ക് റൂട്ട് എക്സ് ഇസ് ഈക്വൽ ടു ടി എന്ന് നമുക്ക് എടുക്കാം, അല്ലെങ്കിൽ എക്സ് ഇസ് ഈക്വൽ ടു ടി സ്ക്വയർ എന്ന് എടുത്താലും മതി. ദാറ്റ് ഈസ് 1/2 root x dx is equal to dt. dx is equal to 2 root x into dt. That is 2 root x means 2t dt. Now replace the function as 4 by pi into sine inverse root x as t and dx as 2t dt, and the integral of this one is x. Now we have to apply the product rule of integration for this. Product rule of integration of which the first function is sine inverse. Inverse function ആണ് first highlight into form out ഉണ്ട്. Sine inverse t into the second one t square by 2 minus integral of derivative of sine inverse t is 1 by root 1 minus t square into integral of second is t square by 2 dt. And you can take the 2 outside, and the 2 will be cancelled throughout this expression. This 2 is this one. 2 will be cancelled, and minus second part is x. Now the problem becomes 4 by pi into sine inverse t into t square. You put this minus inside the bracket, I mean inside the integral symbol. Minus t square dt divided by root 1 minus x t square minus x. Complete the integral. 4 by pi into sine inverse t into t square. And you add, and here this is the turning step, you add 1 there and subtract 1 in the numerator, that is 1 minus t square minus 1. എന്തിനാണ് നമുക്കിത് ഡിവൈഡ് ചെയ്യാം, അതിന് വേണ്ടിയിട്ടാണ്. So when you divide the second part of that one, root of 1 minus t square by root 1 minus t square is simply root of 1 minus t square minus 1 by root of 1 minus x 1 minus t square dt. The first part integral over, that is 4 by pi into sine inverse t into t square plus root of 1 minus t square minus 1 by root of 1 minus t square. And what is the integral of root of 1 minus t square? I think you remember that lengthy formula in root of a square minus x square. X by 2 into root of a square minus x square plus a square by 2 into sine inverse t. Okay. So the answer is 4 by pi into sine inverse t into t square plus x by 2 t by 2 into root of 1 minus t square plus a square by 2 1 by 2 into sine inverse t minus വേറൊരു 1 by root 1 minus x square ഉണ്ട്. For that you write sine inverse t, and finally ഒരു x അവിടെ ആൻസറിലും ഉണ്ട്. Simplify 4 by pi into sine inverse t into t square t by 2 into root of 1 minus t square minus, simplifying these two things on half sine inverse t and minus sine inverse t. So that is minus half sine inverse t minus x. The first and last term you can combine together, that is sine inverse t into t square as the coefficient here and minus 1 by 2 as a coefficient here. So t square minus half plus t by 2 into root of 1 minus t square minus x, and that is 4 by pi into change t with root x, 4 by pi into sine inverse root x minus, for this t square x, 1 by 2 for t it is root x minus root of 1 minus x minus x. And simplifying that one, take this one as LCM, 4 by pi into sine inverse root x into 2x minus 1 by 2. You multiply this root x inside the bracket, that will be x inside the bracket, that is root of x minus x square divided by 2 minus x plus c. This is the given answer in the solution part. Next question is question number 20 in miscellaneous exercise, integral root of 1 minus root x by 1 plus root x dx. It is little difficult, and here also we use the substitution for root x. Better you know the formula 1 minus cos theta by 1 plus cos theta, അല്ലെ 1 minus cos 2 theta by 1 plus cos 2 theta ഒക്കെ നമുക്കറിയാം. ആ ഫോമുല ഉള്ളതുകൊണ്ട് റൂട്ട് എക്സിന് ഞാൻ കോസ് 2 തീറ്റ എന്ന് കൊടുത്തു. കോസ് 2 തീറ്റ എന്ന് കൊടുക്കാം, കോസ് തീറ്റ എന്ന് കൊടുക്കാം, സൈൻ തീറ്റ എന്നെല്ലാം കൊടുക്കാം, നോ പ്രോബ്ലം. ബെറ്റർ ഐ തിങ്ക് ബെറ്റർ യു യൂസ് റൂട്ട് എക്സ് ഇസ് ഈക്വൽ ടു കോസ് 2 തീറ്റ. So differentiating 1 by 2 root x dx is equal to minus sin 2 theta into 2 d theta. dx, you cross multiply this 2 root x to right side, minus 2 root x into 2 sine 2 theta d theta. What is root x? Cos 2 theta. So minus 2 into 2, 2 into 2, minus 2 into 2 cos 2 theta and sine 2 theta d theta. So substitute for dx as minus 4 sine 2 theta cos 2 theta d theta. And inside the bracket is root of 1 minus cos 2 theta by 1 plus cos 2 theta. You know the formula, 1 minus cos 2 theta, 2 sine square theta. 1 plus cos 2 theta, 2 cos square theta into, take minus 4 outside. Okay, now let us write that sin theta by cos theta as tan theta, അല്ലെങ്കിൽ അത് sin by cos തന്നെ കടന്നാലും മതി. sin 2 theta cos 2 theta. For that sin 2 theta you can substitute 2 sin theta cos theta into, and cos 2 theta you write 1 minus 2 sin square theta. സിംഗിൾ വേരിയബിളിലേക്ക് കൺവേർട്ട് ചെയ്തുകൊണ്ട് വരാനുള്ള ശ്രമമാണ് ഞാൻ നടത്തിയത്. അപ്പോൾ ഒരു കോസ് ക്യാൻസൽ ചെയ്ത് പോയി ടാനിനകത്ത് സൈൻ ബൈ കോസ്, ആൻഡ് അഗെയിൻ 2 sin is there and take 2 outside, it will be minus 8 sin square theta into 1 minus sin square theta. Now minus 8 outside, sin square theta minus 2 sin raised to 4 theta d theta. The first one, sin square theta, it is easy because we have the formula for sin square theta as 1 minus cos 2 theta by 2 multiplying it. And the other sin raised to 4 theta as 1 minus cos 2 theta by 2 the whole square along with the 2. And ini careful ആയിട്ട് ചെയ്യണം. minus 8 into, for this one, what is integral? Theta. Because this one is integrating with respect to d theta. Theta by 2. What is the integral of cos 2 theta? Sin 2 theta by 2. Because ഈ 2 ഉള്ളതുകൊണ്ട് sin 2 theta by 4. Take this 2 into this 2 the whole square, you take 1 by 2 whole square outside and it will be 1 by 4, and cancelling 2 you will get 1 by 2 minus 1 by 2 into expand 1 minus cos 2 the whole square, that is 1 minus 2 cos 2 theta plus cos square 2 theta again. And the first part integral over theta by 2 into sin 2 theta by 4 minus half into, integrate this 1 theta, integrate this cos 2 theta sin 2 theta by 2. ഇവിടെ നമുക്ക് വെട്ടിക്കളയാം. ഇവിടെ cos സ്ക്വയറിനെ ഇൻ്റഗ്രേറ്റ് ചെയ്യാൻ പറ്റില്ല, അതുകൊണ്ട് വീണ്ടും ഇതിനെ 1 പ്ലസ് കോസ്, ഇവിടെ 2 തീറ്റ ആയതുകൊണ്ട് 1 പ്ലസ് കോസ് 4 തീറ്റ ബൈ 2, ബിക്കോസ് we need to convert the square of trigonometry into multiple angle form. Now ഇത്രയും ഇൻ്റഗ്രൽ ഓവർ, ഇനി ഇതിനെ ഇൻ്റഗ്രേറ്റ് ചെയ്യണം. ആൻഡ് വാട്ട് ഈസ് ദാറ്റ്? ഇതങ്ങ് അകത്തേക്ക് മൾട്ടിപ്ലൈ ചെയ്യുമ്പോൾ തീറ്റ ബൈ 2 സൈൻ 2 തീറ്റ ബൈ 4 മൈനസ് ഹാഫ് തീറ്റ, ഇത് കട്ടായി പോവും, ആൻഡ് 2 കട്ടായി പോവും, മൈനസ് ഇൻറ്റു മൈനസ് പ്ലസ് സൈൻ 2 തീറ്റ ബൈ 2, ഇത് നമുക്ക് സിംപ്ലിഫൈ ചെയ്യാം. സൈൻ 2 തീറ്റ ബൈ 4 സൈൻ 2 തീറ്റ ബൈ 2, ഈ മൈനസ് 1 ബൈ 2 ഇത് ഇവിടെ വരുമ്പോൾ മൈനസ് 1 ബൈ 4 വരും. 1നെ ഇൻ്റഗ്രേറ്റ് ചെയ്യുമ്പോൾ തീറ്റ വരും. കോസ് 4 തീറ്റയെ ഇൻ്റഗ്രേറ്റ് ചെയ്യുമ്പോൾ സൈൻ 4 തീറ്റ ബൈ 4 along with this minus 1 by 2 into 1 by 2 minus 1 by 4. It is little difficult. You look it closely and simplify it. Now simplifying, theta by 2 theta by 2 cancel, sin 2 theta by 4 negative, sin 2 theta by 2 positive. We will get sin 2 theta by 4 positive and minus 1 by 4 theta and sin 4 theta divided by 60, that is minus 8 into sin 2 theta by 4 minus theta by 4 sin 4 theta by 60. Multiply minus 8 inside the bracket, you will get sin minus of sin 2 theta 2 sin 2 theta and minus into minus plus 2 theta, minus 8 into 4 will be cancelled and we will get 2 theta and sin 4 theta by 2. Anyway, നമുക്ക് ഈ തീറ്റ എല്ലാം മാറ്റണം, because we assumed root x is equal to cos 2 theta. So sin 2 theta is equal to root of 1 minus cos square theta എന്ന് എഴുതാം. root of 1 minus cos square 2 theta. cos 2 theta root x ആണ്, അപ്പോൾ cos square 2 theta x ആവും. So minus 2 into root of 1 minus x 2 theta. What is 2 theta? Cos inverse root x. And sin 4 theta വീണ്ടും സിംപ്ലിഫൈ ചെയ്യുക, 1 by 2 into 2 sin 2 theta cos 2 theta. 2 cancelled, and for sin 2 theta you can substitute root of 1 minus x, and for cos 2 theta you can substitute root x. അതൊന്നുകൂടെ റീഅറേഞ്ച് ചെയ്താൽ മതി. minus 2 into root 1 minus x plus cos inverse root x. ഈ root x അകത്തോട്ട് കൊണ്ടുപോകുമ്പോൾ it will be x minus x square. Next question is question number 26 in NCERT miscellaneous exercise. Integral 0 to pi by 4 sin x cos x dx by cos power 4x plus sin power 4x. Similar to one of our previous problem, here the denominator contains the power of sin and cos is 4. To integrate this one, we make a transformation like this, dividing throughout by cos square alla cos raised to 4x. Now the question is integral 0 to pi by 4 sin x cos x by cos power 4 and cos power 4 by cos power 4 1, and this is tan power 4x. Simplifying, the numerator becomes sin by cos tan, and one cos will be cancelled, and the remaining 1 by cos square is there. You can write it as 6 square x. Now the limits are from 0 to pi by 4 tan x 6 square x by 1 plus tan square x the whole square. It is very clear because the derivative of tan square is 2 tan x into 6 square x lies in the numerator. 2 illanne ullu. So assume u equal to tan square x, du equal to 2 tan x square x. So when x is equal to 0, u equal to 0. When x is equal to pi by 4, u equal to tan square pi by 4, which is 1. So new limits are from 0 to 1. Du by 2 by 1 plus u square, that is half into integral du by 1 plus u square, that is tan inverse u within the limit 0 to 1. So the answer is 1 by 2 into pi by 4. So it will be pi by 8. And question number 27. See this, another question 27. Integral 0 to pi by 2 cos square x dx by cos square x plus 4 sin square x. നമുക്ക് തുടക്കത്തിൽ കാണുമ്പോൾ തോന്നും ഇത് കോസ് സ്ക്വയർ കൊണ്ട് ഡിവൈഡ് ചെയ്യാമെന്ന്. പക്ഷേ കോസ് സ്ക്വയർ കൊണ്ട് ഡിവൈഡ് ചെയ്താൽ ന്യൂമറേറ്റർ 1 ആയി പോകും. വി വിൽ നോട്ട് ഗെറ്റ് എ ഡെറിവേറ്റീവ് സ്റ്റെപ്പ് ഇൻ ദെയർ. സോ യു അഡ്ജസ്റ്റ് ദ പ്രോബ്ലം. You know the formula cos square plus sin square x is 1. So you split this 4 sin square x as 1 sin square plus 3 sin square and add 1 sin square along with this cos square. You will get 1 cos square plus sin square 1 and remaining 3 sin square there. Now the problem becomes integral 0 to pi by 2 cos square x dx by 4 1 plus 3 sin square x. For this sin square x, you can write it as 1 minus cos square x. So 4 plus 3 into 1 minus sin square x. That is 4 plus 3 into 1 minus sin 1. Okay, again 1 plus 3 sin square x. 3 sin square x can be written as 3 into 1 minus cos square x. So 3 plus 1 4 minus 3 cos square x. Now this function contains only cos square x in numerator and denominator, but here there is another problem. The same degree in numerator and denominator. When an algebraic expression comes with the same degree in numerator and denominator, we must divide first. Like this question, you change that cos as u for dividing, only for dividing. Assume this one is u square by 4 minus 3 u square and divide it. U square minus 3 u square plus 4, and the quotient is minus 1 by 3. Minus 1 by 3 into minus 3 square is u square. Minus 1 by 3 into 4 is minus 4 by 3. Subtracting, you will get the remainder as 4 by 3 and quotient as 1 by 3. So dividing cos square by 4 minus 3 cos square, you will get one part is minus 1 by 3 and the remainder by divisor is 4 minus 3 cos square x. Okay. Now we can integrate the first one, no problem, minus 1 by 3 into x, and we can put the limit 0 to pi by 2. And the second one, 4 by 3 into integral 0 to pi by 2 dx by 4 minus 3 cos square x. Here we must apply the transformation divided by cos square x. We discussed 3 questions similar to this one, divided by cos square x in numerator and denominator. Now the second part will be 4 by 3 into dx by cos square x is e square x and 4 6 square x minus 3. Again you change the denominator 6 square x as 1 plus tan square x because we need the numerator for derivative part. Now 4 into 1 plus tan square x is 4 plus 4 tan square x minus 3. So the second part becomes 4 by 3 into integral 0 to pi by 2 c square x by 1. 4 minus 3 is 1 plus 4 tan square x. And here you can assume tan x as u, not tan square, tan x as u, du as c square x, x equals 0, u equals 0, x equals pi by 2 equal to infinity. So the second part becomes 4 by 3 into 0 to infinity du by 1 plus 2u the whole square. You know the integral of that one. 1 by a 1 by 1 plus x square form ആണത്. അത് tan inverse x ആണ്. So 4 by 3 into tan inverse 2u, and here there is a coefficient, so we must divide by 2. And the first part is pi by 6, you know it is 1 minus 1 by 3 into 0 to pi by 2, put upper limit, pi by 2 into minus 1 by 3 will be pi by 6. Pi by minus pi by 6 plus 4 by 6. 4 by 6 tan inverse infinity is pi by 2. Okay, so the second part is 4 by 6 into pi by 2, and simplifying you will get pi by 6 for this. And the next 5 questions are your homework. This is question number 13 NCERT miscellaneous exercise, integral 0 to pi by 4 sin x plus cos x by 9 plus 16 sin 2x. We discussed a question similar to this one. You can split the denominator as sin x plus cos x by 9 plus 16 into 1 plus sin 2x minus 1 and adjust it like this. 9 plus 16 is 25 minus 16 into 1 minus sin 2x, you take minus outside, and for that 1 minus sin 2x, you write it as sin x minus cos x the whole square, because the numerator is sin x plus cos x, and you should write the denominator as sin x minus cos x for this 1 minus sin 2x for this 1 minus sin 2x. Okay. And second question similar to that one, integral pi by 6 to pi by 3 sin x plus cos x by sin 2x root. Here also this root of sin 2x can be written as 1 plus sin 2x minus 1, and it can be written as 1 minus sin x minus cos x the whole square, because numerator is sin x plus cos x. Okay. And apply the limit for u equal to sin x minus cos x, and substitute it and change the limit. And next question, integral 0 to pi by 2 sin 2x into tan inverse sin x, and replace sin 2x as 2 sin x cos x into tan inverse sin x dx, and assume u equal to sin x and change the limit. The problem becomes 2 into integral 0 to 1 u tan inverse u du. And next question is question number 33. It's an important one. Integral 1 to 4 mod x minus 1 plus mod x minus 2 plus mod x minus 3 dx. You split it. Integral 1 to 4 mod x minus 1, 1 to 4 mod x minus 2, 1 to 4 mod x minus 3. And for question number, first part of that question, integral 1 to 4 mod of x minus 4. No need to apply modulus for this one within this limit, because from 1 to 4 that x minus 1 is positive, so you avoid modulus symbol, no problem. And the second one, integral 1 to 4 mod of x minus 2. Here we need to split it. Integral 1 to 2, the function is negative, so you apply a negative sign for that one. For converting that one into positive, that means integral 1 to 2, 2 minus x plus integral 2 to 4, x minus 2 itself, because in the limit x is equal to 2 to 4, 2 തൊട്ട് അവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ x minus 2 പോസിറ്റീവ് ആയിരിക്കും. അപ്പോൾ അതിന് മോഡിൻ്റെ ആവശ്യമില്ല. Similar to that one, integral 1 to 4 mod of x minus 3, you can split it as integral 1 to 3 3 minus x by applying minus into inside bracket, I mean inside the modulus symbol, and 3 to 4, no need for that modulus symbol, it is x minus 3 because that function is positive. And the next question, question number 23 in miscellaneous exercise, integral, it is an indefinite integral question, tan inverse root of 1 minus x by 1 plus x, and it's very easy. We should get a function involving tan inside the square root. For that you assume x is equal to cos 2 theta and dx is equal to minus 2 sin theta d theta, and everybody must complete this 5 question by yourself and send it to me. After this we will start application of integrals. Okay.